All right, as you can tell, I decided to cut these videos into two videos. So now we're looking at exercise 4 and 5, talking about map scale and map projections. But first, let's go ahead and start with exercise 4, map scale. And again, that is exercise 4 in the lab manual, which starts on page 15. All right, so map scales, specifically graphic scales, are some of the most important features that you'll find on a map. And a graphic scale is probably the one that you're going to be most familiar with. You can see some examples of them down here at the bottom. But scale basically just indicates how much of Earth is being reduced and being shown on the map. And so the reason that graphic scales are really great is because if you have a map with a specific map size on it, no matter how large or small that map becomes, if you're blowing the image up or if you're making it smaller, that graphic scale is going to change with the map. Here is a great example of the graphic scale representation. So again, a scale on any map is going to show you how much area on the paper or image is going to be represented in the real world. So this is representing 10 miles, and this is, LA or Long Beach is down here. And when that map becomes smaller, the graphic scale is going to be changing with that. So it's always great to know that the graphic scale on any map is going to remain accurate regardless of how big or small that map gets. And in addition to the graphic scale, we are going to look at two other scales, a fractional scale as well as a verbal scale. As you can see, the fractional scale is more or less a representative fraction, that is an expressed scale of the map fraction or ratio. The fractional scale, which is also called a representative fraction, expresses the scale of a map as a fraction or ratio. And so you can see here again, that's either going to be 1 over 24,000 or 1 to 24,000 up here. And that basically just means that one unit represented on the map equals 24,000 of those units on Earth's surface, aka in real life. So for the example in your lab manual, 1 centimeter on the map is going to be representing an actual distance of 24,000 centimeters on Earth. And sticking with that example, if it's decided that it was 1 inch on the map, then 1 inch on the map would represent 24,000 inches on Earth. There are also verbal scales, which we won't really be calculating here so much, but let's figure out how to actually calculate the map scale to the real life scales. And we will be doing that predominantly using the fractional scales. So go ahead and turn to page 16. We are going to be computing distances with fractional scales. Thankfully, the lab manual has provided us with formulas in order to convert the measured distance to actual distance. We're going to use the example in the book in order to do that. So, for example, if we have a map with a scale of 1 to 50,000 and a measured distance of 22 centimeters on the map, we have to figure out what that actual distance calculates to in the real world. So what we're going to have to do is take our units, multiply that by our fractional scale, and that is going to leave us with 1,100,000 centimeters. But it's really hard for us to do something with that because who can really ballpark or have a general understanding of how far or what the distance is of 1,100,000 centimeters. So we need to convert this into units that make more sense to us. So we're going to convert this from centimeters into kilometers. And so thankfully our lab manual has offered that formula as well. So we're going to take our answer of 1,100,000 centimeters, divide that by 100,000. That's the conversion in order to get to kilometers. And then we are going to be left with 11 kilometers. So again, this section down here breaks it down more simply so that you can follow along and read through that in order to have it, hopefully make a little bit more sense. So take a second, pause here, read through it again before we move on to the next page where we're going to do one that is mildly more complex. All right, using another example out of the lab manual, if we have a scale of 1 to 24,000 with a measured distance on the map of 8.25 inches, we have to figure out what the distance is in real life. So, using our calculations again, using our fraction, multiplying our fraction 24,000 by the measured distance, we are going to multiply 8.25 by 24,000, and that is going to give us 198,000 inches. Again, that doesn't really help us much because we can't really, understand what that distance means, so we need to convert it. So thankfully, again, the lab manual has provided us with a way to convert that. So we're going to go ahead and plug that in. 198,000 inches divided by 12, that would tell us the amount of feet. It's going to be 16,500 feet. Or you can divide that, which is our number, in order to figure out the miles, and that's going to leave us with 3.1 miles. Again, this section down here helps to break down how to do those calculations in a little bit more step-by-step detail. So again, go ahead and take a look at how those numbers were plugged in before you try to do this on your own. But before I let you do the practice exercise, I'm going to let you take a stab at this one. So if we had a map scale of 1 to 36,000 and a measured distance of 12.2 centimeters on the map, what is the actual distance in real life? So first, we have to figure out what our fraction is so that we know what we need to multiply. So jumping back up here, we need to figure out and see if any of these, match. We're going to go ahead and sure enough, plug in our 1 over 36,000. So now we know that we need to multiply our measured distance of 12.2 centimeters times 36,000 because that is the fraction on the map. Once we do those calculations, we are going to be left with 439,200 centimeters of real life distance. Again, that doesn't mean much to us, so we need to be able to convert that. So for this case, you are going to be asked to convert it into meters. Thankfully, we can do this. So we're going to take our 439,200 centimeters, divide it by 100, and that is going to leave us with 4,392 meters. Again, you could divide that further if you wanted to put it into kilometers. But again, these are the steps in order to calculate, and that is more or less what exercise 4 is going to ask you to do. So keep in mind that you need to identify a fractional scale as well as the unit and measured distance in order to compute the distances in the real life using fractional scales. That more or less covers everything you're going to need for exercise 4, so take your time while calculating those things while I jump back up to the top to quickly talk about exercise 5. There are no calculations that you're going to have to do for exercise 5, but what will be very important is that you take the time and read through the information in your lab manual. That is your supplemental reading, and I guarantee you that all of the answers that you will be asked in your practice exercise as well as your lab will be able to be deciphered using all of the information in your supplemental reading in your lab manual. I've also gone ahead and posted a video about map projections. I think it's relatively fun, so hopefully that will provide some additional knowledge for you. But like I said, I cannot stress enough the supplemental reading that you should be doing in your lab manual in order to answer the questions for exercise 5 dealing with map projections. So go ahead and watch the video. It is posted below this lecture. Thanks, and good luck.